We're in section 3.4, page 331, and I would like for you to try number 7 through 10. I will pause the video, you do the same thing, and check back to make sure that you got what I did. Okay, don't just check your numbers, also check the direction of the comparison symbol. So if you look at 7 and 9, the comparison symbol did not change because we multiplied and divided by a positive number. But if you look at 8 and 10, on 8 we multiplied by a -2, and you'll notice that -20 is no longer less than -40. In fact, it's greater than. And on 10, -2 is not less than -4, it's greater than -4. All right, so that will help us develop our rules, which I think some of you have heard this one before. So let's flip to the next page. Number 11 says, write stays the same or changes in each blank to complete our second tool for solving inequalities. Then follow the remaining instructions in the box. If you multiply or divide both sides of an inequality by a positive number, the direction of the comparison symbol, looks like we should say, stays the same. If you multiply or divide both sides by a negative number, the direction of the comparison symbol changes. And then they would like for us to solve each inequality, and then they want us to graph the solution set and choose one number from the solution set and check to see that it makes the inequality true. Okay, so with this first one, 2 times x is less than 10. Let's solve this by undoing the 2 times x by dividing both sides by 2. Hopefully you see how those 2's divide out, and I have x is less than 5. So let's put that on our number line. It doesn't include 5, so I'm just going to put an open circle, less than, shade to the left. To check, I need a number that's less than 5. I could use 4. Well, I'll go ahead and do that. So 2 times 4, is that less than 10? 8 is less than 10. Yes, so that checks out. All right, let's look at this next one. I have -3z is greater than or equal to 12. So I need to undo the -3 times z. So I divide by -3. Hopefully you see how -3 divided by -3 gives us a positive z. But since I have divided by a negative number, I no longer have greater than or equal to. It will now be less than or equal to -4. All right, so let's put my solution on the number line. And so we were including -4, so we'll color in our circle and then shade to the left. So to check this, I'm going to choose a number less than -4. It really wouldn't matter what I did as long as it was less than or equal to -4. I'll go ahead and choose -5. So we have -3 times -5. Is that greater than or equal to 12? So that gives me 15 greater than or equal to 12. Yes, that checks out. Okay, next we have 1/4 times t is greater than -3. So if they're multiplying t times 1/4, how do we undo multiplying by a fraction? Well, we have to divide by it, so when you divide by a fraction, recall that you must multiply by the reciprocal. The reciprocal of 1/4 is 4/1. Reciprocal is just a fraction flipped upside down. So you see the 4's divide out, and we're left with t. Now this is not going to change because I just multiplied by a positive number, and the -3 times 4 is -12. Okay, so let's put the -12 on our number line. Unit less, unit more. Okay, open circle, and we'll be shading to the right because it's greater than. All right, so I'm going to check this by choosing a number that is greater than -12. And I'm going to make this really easy on myself. 0 is greater than -12. So 1/4 times 0, is that greater than -3? Well, I get 0 is greater than -3, so yes, that checks out. So go ahead and pause the video and do this next one on your own, and then check it. Okay, so what are they doing to b? They're multiplying it by -1/3. How do I undo multiply by -1/3? Well, it looks like I'm going to divide it by -1/3, so I multiply both sides by the -3/1. So that gives me b. Now, since I multiply both sides by a negative number, it is now going to be greater than or equal to, and then 2 times -3 is -6. So here's my -6 on the number line, and I filled it in, and it's greater than or equal to, so I'm shading to the right. All right, so we need to check this. I need to find a number that is greater than -6. The easiest one to use is 0. So I have -1/3 times 0. Is that less than or equal to 2? Well, I get, oops, that's a 2. I want my question mark right here. 0 is less than or equal to 2, so that checks out. Okay, so I'm going to move this up here. And again, I want you to pause the video, and I want you to try the 2 did you get it problems. Okay, how did you do? All right, let's go to the next page. The types of inequalities that we've been solving in this lesson are called linear inequalities because we've seen that the graph of an equation with the input appearing only to be to the first power is a line. Here's a review of the steps we've discovered along with some bonus material. So I'm going to go ahead and move this up just a tad, and I'm going to give us just a little bit of space to work on this, solve this inequality here. And I'm going to use those tools. I'm going to read them. Let's pause this while I go ahead and write this down again. Okay, done. Step 1, simplify both sides of the inequality, if necessary, by multiplying out any parentheses and combining any like terms. Well, both sides of this inequality need some help. On the left side, I need to distribute the -2. That gives me -2x plus 10 is greater than or equal to. On the right side, it looks to me like I've got 2 like terms. I've got the x and the -5x, so we'll need to combine those. X minus 5x is a -4x, and then minus, erase, -8. Okay, and then step 2 asks us to use our tools to rearrange the inequality so that the term containing the variable is all by itself on one side. As I mentioned to you before, I really prefer putting our variables on the left side of the inequalities for the times that we need to interpret what that inequality means. So to move that -4x over to the left side, I will need to add it to both sides. Okay, that gives me 2x plus 10 is greater than or equal to -8, and then I'm going to move that 10 on the other side. So I'm going to subtract 10 from both sides. Okay, so that's going to give me 2x is greater than or equal to -18. All right, and then it says step 3, use tool number 2 to change the coefficient of the variable to 1. Make sure that you change the direction of the inequality if you multiply or divide by a negative number. Okay, so I just have a +2 that they're multiplying x by, so I don't have to change the direction of the inequality, do I? So I have x is greater than or equal to -9.